Hello all, welcome back to the lecture series of Python, and in today's video we'll be talking about bitwise operators and assignment operators. In the last video we actually covered arithmetic operators, logical operators, relational operators, and membership operator. So if you haven't watched that video yet, so the link to the video is in the description below, so make sure you watch that video as well. So let's move forward with bitwise operator. Now, before diving into the bitwise operator, you need to understand two things. That is the truth table for AND, bitwise AND operator, and the truth table for OR. So basically, when you're comparing bits, the bits are either 1 and 0. So if one of the bits is 1 and the other bits is also 1, so 1 and 1, I'm talking about the truth table for AND operator. So if you see 1 and 1 is 1, 1 and 0 is 0, 0 and 1 is 1, 0 and 1 is 0, 0 and 0 is 0. So basically, whenever, if there exists at least one 0 and you're using, you have multiple bits, and if there exists one 0 and you're using the AND operator, the result will be 0. But if you talk about the OR operator, it is in the contrast of the AND operator. It is totally opposite. So if you see 1 or 1 is 1, 1 or 0 is 1, 0 or 1 is 1, 0 or 0 is 0. So if you see, if we have at least one single bit which shows 1, one single bit with value 1, then OR operator results 1. So in OR operator, to get results as 0, you have to have all the bits as 0. So that is the basic thing that you need to understand before diving into the bitwise operator. Now, I have instantiate two variables, x is equals to 10 and y is equals to 15. And if you see, I have mentioned the binary value as well, because the bitwise operator actually compares the bits. So we have to have understanding of the binary values. So the binary value of b is 0b100, 1010. So the binary value, how do we know it's a binary value? Because binary value starts with 0b. And the binary value for 15 is 0b11 and 11. Just in case you want to see binary value of any number, you just have to write print bin, and then you have to input any number you want. So let's say 20. So you get the binary value of 20. So the binary value starts with 0b, and the rest is the binary value 10100. So that's how you can actually get the binary value of any number. Now let's talk about the bitwise AND operator. So if I write print x and ampersand y, x ampersand y, or you can pronounce it as x bitwise or and y, or you can just simply say x and y. They all are the same. So if I execute it, shift enter, you get 10. So how do we actually get 10? So let's just compare it. We compare it bit by bit. So the first bit is 1, and here the first bit is 1. So 1 and 1 is 1. Let me just, yeah. So 0b1. So the first bit is 1. The second bit is 0, and the other bit is 1. So 1 and 0 is 0. If you see 1 and then 1, it is 1. 0 and 1 is 0. So if you see the binary value of 10, so how do we check the binary value of 10? Bin 10. So if you see the binary value is 0b1010, and that's what we calculated. So that's how we got the result 10 and 15, 10 bitwise 15, we get 10. So that's how the AND operator works. Now let's talk about the OR operator. It is totally opposite of that AND operator. So if you write X, or you can simply call it pipe operator also, X or Y. So let's say, let me just check what value we are supposed to get. So it should be 0b, and then the first value is 1. So sorry, the first bit is 1 and the second bit is 1. So 1 or 1 is 1. The second bit is 0, and the second bit is 1. 0 and 1 is again 1. The third bit is 1, and here the third bit is 1. So 1 or 1 is 1. Again 0 and 1 is 1. So if you see, we should get 15 as answer. We don't need to check it. We just should, we get 15 as an answer. So that's how basically the OR operator, bitwise OR operator works. So if you have at least one value, one bit as 1, you will get the value as 1. If your all the bits are 0, you will get 0. But in AND operator, if one of the bit is 0, then you get you get the result as 0. Now moving forward with the Zoro operator. So the Zoro operator works in a very, very different way. but not so different way. So in the Zoro operator, if one of the bits is 1 and the other bits is 0, then and then only you will get 1. Otherwise, you will get 0. So what do I mean by that? Let's say you have a pair of bits 1 and 0. Then the Zoro operator will give you 1. And if let's say you have a pair of bits 0 and 1, so 1 and 0 is same as 0 and 1. So again you will get the result as 1. But let's say you have bit 0 and 0, you have pair of bit 0 and 0, you will get 0 in the case of Zoro operator. Now if you have bits as 1 and 1, then also you will get the result as 0 in Zoro operator. The Zoro operator results 1 if either of the if one of the bits is 1 and the other bit is 0, then and only then you will get the result as 1. So how do you use it? X, it is called the caret operator, x caret y. You just need to put up the space in between. I'm just putting it for the sake of understanding. Okay, so let's check what value we are supposed to get. So 0b. Now first bit is 1 and then 1. So we should get 0 because in Zoro operator, if one of the bits is 1, then the other should be 0. Then only we'll get 1. So here we get 0. Now we get 0 and the other bit is 1. So it is 1. 1 and 1, it is again 0. 0 and 1 is again 1. So we get 5. So let me just check the binary value of 5 over here. Sorry, bin 5. So if you see the binary value of 5 is 0b101. Now you must be wondering, we got 0 over here and we didn't got 0 over here. So basically if you put 0 after the b, it doesn't make any difference. So the what makes difference if the 0 is after here. So that makes actually difference. It doesn't make a difference over here. Okay, so I hope you were able to understand the Zoro operator because it was different from and OR operator. Now let's talk about the Bitwise Not Operator. So Bitwise Not Operator gives you the complement of any number, right? So how do we actually use it? It is simple, print tilde, it is called the tilde sign, and x. So, okay, so what was the value of x exactly? Let me just print out the value of x. Okay, so print x. So you get the value of x was 10, but the complement should be minus 10, right? But we are getting minus 11. So basically the bitwise not operator works in a different way, right? In order to get the complement of number using the bitwise not operator, we need to do one thing. We just have to add +1 to the result. We just have to add. So basically what we're doing, the complement of x, that is 10, it is returned as +1 into minus. So what do you mean by that? So the value of x was 10 and we added +1 to it, so you got 11 and then minus 11. That's how you get it. So in order to get a perfect complement by using the bitwise operator, what you can do is just +1 to that particular result, the result of the bitwise not operator. So you get the complement of the particular value. So bitwise operator is also known as the complement operator. So basically it just negates the statement, it gives you the complement of the value. If it is 5, it will, if the value is 5, it will result as -5. Provided you write in this way. Otherwise it will be -x. If it is positive, it will go up and then you will get a negative sign if it is negative. So let me just give you an example. If what happens if it is negative? Tilde -5. So you get 4, right? We go down and then we add a complement. So minus the complement of negative is positive. So that's how you can use the bitwise operator. Now the bitwise right shift operator. Okay, so the bitwise right shift operator is very interesting actually. So let's say I write x right shift operator 1. Let me just print out the value 1. So I get 5 only, but the x value was 10. So why do I get 5? So the bitwise right shift operator, it is same as dividing the value with some power of 2. And here we are actually dividing with the power of 2 as 1. So it is basically x, it is same as saying x divided by 2 to the power x, floor division 2 to the power 1. So if you don't know what is floor division, I've actually covered in the previous video and I've pasted the link in the description. So make sure you watch that video as well. So if you see, bitwise right shift operator gives out the result and it is same as dividing the value with some power of 2. So if I write 20, right shift and 2, so it will be 20 divided by 2 to the power 4, and you will only get the number as whole number, you won't get the decimal part. That's why I'm using the floor division. So if you divide 20 with the some power of 2, sorry, 2 to the power 2, if I write 3, so it is 2 to the power 3. So you get, so 20 divided by 2 to the power 3. What is 2 to the power 3? 2 to the power 3 is 8. And 20 divided by 8 is 2 only, because we only get the quotient. We don't get the remainder. So that is the right shift operator. And the bitwise left shift operator, it is same as multiplying the value with some power of 2. With some power of 2. So we get, oh sorry, it is left shift operator. So if you see, x was 10, so I write x left shift 2, so it is 2 to the power 2, so 2 to the power 2 is 4, and 10 into 4 is 40. So that's how you get bitwise left shift operator. Sorry. Now moving on to the assignment operators, we'll talk about how assignment operators can actually make our life easy while writing simple assignment values and in a very concise way. So basically you must have used assignment operators, that is the equality sign, but you can use it in a different way as well. Let's say you want to add, let me just print out the value of x so that we can just keep the track of it. So again, we can see that x holds the value 10. Let's say you want to add 5 to the x. What you can write, what you're supposed to write, you just write, you can write x equals to x plus 5. So what is a better way to write it? Not a better way, but you can say it in a more concise way to write it. So you can just write x plus equals to 5. So this is equivalent. So this is equivalent to this. And then I'm going to print out print x. Again, at every step, I'm going to print out the value of x. And then let's say you want to subtract, minus, so you want to subtract 5 from the x. It is as simple as writing x minus equals to 5. Now, in the same way, let's say you want to multiply the value of x. You just have to write x star equals to 5. It is same as writing x equals to x multiply 5. And here also we write, if you want to divide the value of x with 5, you can just simply write x equals to x by 5, or you can write x divided equals to 5. And here also we can just replace plus with the double backslash, which is the floor division. And here also it is x star equals to 5. It is equal into x equals to x to the power 5, and then print x. Lastly, we are left with the modulus operator. So it is basically if you want the remainder when you divide x by 5. So it is x percentage equals to 5. So here we are actually not just calculating the value. We are actually we are actually altering the value, and we are storing it in the variable x. So that is why these are called assignment operators. And then print x. So let me just shift enter and execute the cell, and then you will see the outputs. So if you see earlier, the values at the very start, the value was 10, as you can see over here. And when we added 5 to it, at this step, we get 15. And in this step, 15 minus 5, because x was changed to 15. In this step, 15 minus 5, it was 10 again. And then here we made x as 50 because we multiplied the value of x with 5. So it is 10 into 5, 50. Here, what we did, we basically divide 50 divided by 5. Again, we got 10. So if you see, we get 50, 10, 50, 10.0, right? And then we get x. This is the floor division. So 10 divided by 5, we'll get 2.0. So 2 to the power 5 is 32. And print x, and now 32, when you divide 32 by 5, you get remainder as 2. So at last we get remainder as 2. So that is how you can use the assignment operators. So in this video, we covered bitwise operators and assignment operators. I hope you were able to understand the depth and clarity of bitwise operators and assignment as well. So I will see you in the next video, and thank you so much and stay tuned.